Now we're going to have Dr. Joanna Bloese. She's the current Ornamental Entomology Extension Specialist at CTAHR and came to us from UC Davis with a PhD in entomology. Her research focuses on plant-insect interactions, specifically sustainable integrated pest management strategies. Her research includes developing resistant management strategies for control of thrips and chemical efficacy trials. She also has a degree in studio art and is a collaborator in a global art science fusion program that aims to bridge the gap across disciplines and connect innovators. She strives to bring creative problem-solving perspective to her research and pest management tactics. Dr. Bloese will be discussing ornamental pest interceptions and chemical efficacy trial update. Dr. Bloese.
Thank you, Glenn. I wanted to thank HFNA for having me. I know how much work goes into this. Judy, Eric, Russell, everybody. Thank you so much for having me. So today I wanted to just give a little update under the larger umbrella of precision nutrient management, specifically for pest control. I have a couple branches of my research that kind of fit into this category, so I thought this is what we could talk about today. Just a quick overview of what I'll be going over. What is precision agriculture? What's precision agriculture or nutrient management for pest control? How does it relate to Hawaii ornamentals? Silicon technology, you guys have heard me talk about silicon for a while now, so we'll talk about a little bit of the past, the current, and the future, what's coming for the silicon. And then new data for Korean natural farming. That was almost a 2-year trial now in the field, so we have some good data there. And then the results for both of those, the challenges we ran into, as always, run into fun challenges, and future work you guys can look forward to. So I really liked these definitions for precision agriculture in case this is a new concept. I'm just going to read this definition. So precision agriculture is an art and science of utilizing innovation, site-specific techniques for management of spatial and temporal variability using affordable technologies. And it enhances output, efficiency, profitability of agricultural production in an environmentally responsible manner. So a lot of times we hear this concept applied to row crops or orchard crops. Big monocultures, we have lots of variability in the field. How does that apply to us in Hawaii ornamentals where we're working with potted plants a lot of times? We have sterile media, cinder, rock. We don't always have that same variability. And so how can we harness this kind of new precision technology? And oftentimes that soil or media, I should say, is sterilized as well. So I really wanted to focus on the nutrient management side of things and how we can adopt that to our needs. So the concept for precision nutrient management is the science and practice directed to link soil, crop, weather, and water factors with cultural irrigation and water conservation practices to achieve optimal nutrient efficacy, crop yields, crop quality, and health and economic returns, of course. And if done effectively, it can reduce off-site transport of nutrients, fertilizers, aka, which will reduce our impact of farming on the environment, right? So in the context of Hawaii, what do we mean by this? Well, I think it's really important to note that actually most health plant problems are caused by abiotic factors. So not insects and disease necessarily. It was interesting for me to hear the ornamental agents talk about the rose beetle damage. One, it was on that variety, which you have some genetic selection for that. But also, Russell seemed to think it was on those that were particularly stressed. So we want to keep healthy plants. And by managing our nutrient precisely so that our plants don't have too much nitrogen or are stressed by having too little nutrients, maybe we can have optimal health for our plants. There's also other ways we can involve nutrition to help with our pest management. So that kind of brings us into the silicon technology. Many of you are familiar with the silicon. The silicon technology we used was silicon dioxide. It's a fertilizer, so it's not categorized as a pesticide. And silicon, essentially, you use the plant resistance inducers as this environmentally friendly way to decrease pest pressure or populations in your field. And you can do this. It does this in a number of different ways in which we can do that. So there's a lot of SI research out there, but there's very little in epiphytes and in tropical plants. So that's really where ours is focused. Tessie has done some work in tissue culture where she had some phytotoxicity, but on mature plants we haven't had any of that yet, or at all. So before I go on, to get to the results, I really did want to talk about the mechanisms, because in the future, our future research really explores these mechanisms. Are there ways we can exploit these mechanisms by understanding them to then use as another form of pest management? So some of the mechanisms of which SI provides protection against pests and disease is through this induced plant defenses. And if you follow this chart, it's a little bit confusing, but the top is pictures of these phytoliths, which is the black and white pictures on the top of an electron microscope. And those are essentially silicon deposits. And that varies with different species. The shape and size varies too, but it can deter feeding. Another really cool way that the plant can react from the introduction of silicon is it can change the herbivore-induced plant volatiles, so HIPVs, released by the plant. And I just read this new study in 2018 that actually showed it can change the attractiveness of a caterpillar. So a caterpillar that fed on SI-treated plant was more attractive to a parasitoid. So it doesn't just change the way that these plants communicate with each other, and that communication is received not only by beneficials, it's also received by neighboring plants and even that same damaged plant. So it's communicating all around. So you have multiple avenues of which SI could benefit the plant. The use of the plant resistance inducers is considered environmentally friendly. And this is kind of another illustration of, you have the phytoliths here, you have the natural enemies there, and then it's also known to fortify cell walls so that it makes it harder for the insects to feed on, penetrate, and damage the plant. What I really like about working with tropical plants, especially epiphytes, is they're really efficient at sourcing nutrients from the air and water and detritus, leaves that fall on them. And one way they do this is through trichomes. Trichomes are these little hairs on the leaves, so they're actually decent foliar feeders. And silicon, we had a really good effect on orchids. And so these trichomes we've seen in previous research can actually change shape and size. We didn't see the change in number. I didn't do this research. But they didn't see a change in number of the different trichomes, but the base of them got much larger, which actually inhibited or deterred insect feeding. So that was another way in which it kind of protected against insect damage. Understanding the mechanism of which SI is absorbed into the plant, how it's absorbed, metabolized, and used is also something we're interested in. And there's multiple ways it can go inside the plant. One is trichomes, usually at the base. Another is somatal pathway. And then another would be just by diffusion over the cuticle, and then also the polar pores. So there's several different ways. And we did take some data on SI accumulation, so we'll go over that in the future. Another form of nutrition management that we got a grant for from the county, thank you, Glenn, is Korean natural farming. So in Hawaii, Korean natural farming, many people have heard of it. I was new to it when I first got here like 2.5 years ago now, and it intrigued me. I looked at the literature and there was mixed reviews, and little to none had been done in ornamentals. So the appealing thing about Korean natural farming is that you learn to make your own nutrients here on island so that farmers can be self-sustainable. We all know the price of synthetic ferts and pesticides is going up. We're in the middle of the Pacific. We're reliant on transportation. So this was really appealing, and we wanted to try it in the system. It also could be a form of producing an organic market for ornamentals as well. So that was something we looked at also. So the question was, will KNF work on ornamental flower systems? So this is work that was done by my colleague and chair, Dr. Kunhui Wang, in soybeans. And she did find that KNF inputs improved soybean. So it actually, there were fewer weeds that emerged, and they had higher mushroom production post-harvest. So I found that interesting. And then she's a nematologist and soil scientist. So she went on to evaluate, okay, great, this is big enough to see. So she went on to evaluate different nutrients within the soil and other biological factors. And she did find some significance of KNF over conventional. She had a collaborator grower that she was working with. This is in vegetable crops, so this isn't ornamentals. And there were some trends of maybe some possible benefits. Is that benefit enough to use solely KNF and for many years, and you won't see any decline? I'm not so sure yet. There's kind of mixed reviews, as I mentioned. So those are the two systems we've been working with over the last few years, and I'm just going to recap the results from the SI and kind of where that's evolving to, that research. So this was at the Waikea Research Station. If you were at the last field day, you actually got to see these plants in person. And thank you to Tessie Amori. She's not here right now, but we used her Honi variety, and Joanne's Litchi or Imamura selected that, and that was the variety that Tessie was on that magazine, the Hort magazine. So we did get to use that in this trial. We also used a white variety of hers. So I'm just going to get straight to the good stuff, which is yield. So after 6 months, we had increase in yield. The treatments, I'm sorry, I forgot to put the key. I'm so used to, I'm in research mode. So I will tell you, D is control, E is drench only, and F is drench plus foliar. So it is getting double the amount of silicon foliarly every week, one or the other. Drench is getting every 2 weeks. And we have two variety of anthuriums, the Honi and the white. And the A is control, the B is the drench, and the C is the drench plus foliar for the silicon. So we did see a difference. It took about a month and a half before we saw any change at all, but it was really actually variety dependent. So we really saw a much bigger difference in the Honi, even though this looks smaller, it was a greater effect. And then we did the white. And we're not sure exactly why. It could be because thrip damage on white is more pronounced and it's maybe less. But this is total marketable yield. And then we also did SI accumulation. And while none was significant, you did see a slight decrease. You can see how control has higher numbers than the drench plus foliar, and then just the drench is somewhere in the middle. So that's a pretty clear trend, like correlation, even though I didn't run a correlation, but even though it's not significance by looking at the error bars, essentially. We also did this in dendrobiums. We really wanted to use this technology as a form of thrips management and resistance management. Dr. Dong Cha mentioned at the first talk, if we can remember back, about how thrips we have a big resistance issue with thrips. And we have a lot of different thrip species that especially affect anthuriums and especially dendrobiums and orchids. And Elton can attest to this, many people can attest. So we have at least 3+ different species of thrips that affect them, and they have to spray commonly. So we really wanted to help the dendrobium industry out and try it on that. And we had the best success there. We had 3 varieties of dendrobiums. We had lavender, purple and white. I'm just going to shorten that. It was Univi Royale, Univi Mist, and I'm forgetting the third one. And so what we found was that it reduced thrip damage by about half, and it increased, therefore, marketable yield because there was more sprays. And the highest thrips we saw was on the lavender, and it reduced that the most. If we look at the SI accumulation by treatment, the only one that was significant is the white. So there was significantly less SI. Oh, control. There was actually more accumulation. Sorry. Did I get those correct? Okay, sorry. Okay, I think actually in Dendrobium, there was more silicon accumulated in the silicon. So it was opposite of what we were seeing with the anthuriums. And the only one that was significant was in the white variety that we saw a difference in the SI accumulation. So to recap, we also had to spray an insecticide once, and when we did that, the conjunction of SI plus the insecticide, we saw a synergistic effect where it did really well. So that's something we noted, and I wrote here. As I mentioned, in the orchids, it reduced thrips damage by half. We also saw it protected against many fungal pathogens, Fusarium and botrytis in Dendrobiums. And next, we really want to understand what are the different rates we can use. Can we use lower rates in conjunction with pesticides to really help reduce the resistance we see with thrips in the field? So that's kind of our next project. We still don't know optimal timing or frequency of application. So these new field trials that we're going to deploy and have started deploying, we hope to learn more from them. So getting into the results of Korean natural farming, this was done with a collaborator grower, Greenpoint Nurseries. They were very helpful in helping us also take data. So we have yield data. We had 2 different trials with 2 different varieties. One was Anui Nui and one was EEV. And this is yield data over time. And this is from December 2020 to August 2022. And A is control, which is conventionally grown. And B is the addition of KNF. Since we're not doing this in a greenhouse trial, we didn't want to stop doing what we were currently doing in terms of fertilization. So will the addition of KNF help with production and help with reducing pest pressure? You can see there's no clear difference, and the line follows quite closely together over 2 years. And you see that again with the EEV. We actually saw a little more variation in the KNF. So it was a little more variable. And these things aren't standardized. You're not getting them from a factory. That's not that surprising to me, I guess, that we saw that. I should note with the EEV, it had some nematode issues. So we had 4 damaged blocks, and we had 4 healthy. But our blocking was successful in terms of it was non-significant in our model. So then we're looking at the marketable yield in terms of a bar graph, and you can see there's no statistical significance, and they're very, very close together, and that's for the 2 varieties. Also, Russell took height data for these 2 years, and so I want to go over kind of just this is what this quick table is telling you. We ran an LME, a linear mixed model, on thrips damage, yield, and height for both trials. And height was significant for Anui Nui. Even though it's not a huge difference, it's like half an inch, it was consistent enough over that time that we could likely say it could be due to this input of KNF. Everything else was non-significant. I also wanted to look at the nutrients in the soil as well. This was done 6 months into the trial, then we did it again a year and a half into the trial. I'm just showing the 6-month data, and this is a little confusing, but essentially where it's the same, it's yellow, and then whichever side has green is slightly higher. A is control, and B is KNF. So we saw a slight trend towards KNF increasing nutrients, but that trend didn't hold up actually a year and a half into it. So we're wondering maybe why that is. So that was interesting as well. I'm going to talk about the challenges we had. With SI, we had such a high rate. We did have white residue. You can see it on the leaves here, and you can see it on the flower, which would be a problem. You can't really see the white on the white, which is nice. And with the orchids, a lot of them grow white for weddings, and you couldn't see it on those. But that's why our current field trials have a much lower rate. So the other challenges we had, it takes about 1.5 to 2 months to see any benefits. It's not going to fix the problem. It's not a chemical. It's an addition to a system that we hope over time can lengthen the life of these chemicals that we currently have. So all these little things that might help as pesticides become more expensive, etc. So it's an aid, but it's not a silver bullet. So therefore it must be applied with other management tools. And it seems to be variety dependent, so it can't broad brush it necessarily. Challenges with KNF, a big part of KNF is this soil amendment called IMO, which stands for Indigenous Microorganisms. But due to the nature of ornamentals, we weren't able to include that. So everything was foliar. We know anthuriums aren't great foliar feeders, so we were limited in that capacity as well. So that was something that we were hopeful for, but the results were what they were. And then what we're currently doing with SI is we're doing growers field. So we have a grant. We have, thank you to Ken Ogawa and other collaborators, gallons of SI. So if you're a grower and you'd like to try this on your field, we can either help you set up a small trial and collect data if you're on Big Island, or even neighboring islands potentially, because Hannah is also a collaborator on this, and Russell services Oahu as well. And we can also give you the product. We can mail it to you for you to do your own research on it. So we are suggesting a much lower rate from our first trial, which was 3.6 gallons per acre. I'm recommending 2.5, which there's no residue for either product, which is great. And then Dong mentioned efficacy trials, so I just wanted to talk about those real fast. In conjunction with this SI, we want to do efficacy trials of new products on the market and how the old ones are holding up in terms of resistance. As James mentioned, we're really low staff in terms of ag techs. So we have only 2 at Waikea, and they have graciously started making this makeshift giant hoop house so that we can have orchids and do this efficacy trial there. And that's almost done, so hopefully soon we'll have results from that as well. And with that, I finished a little early. Kind of proud of myself. So I want to thank all of my collaborators. I couldn't have done it without them, and all of the funding sources. And I'll take any questions. And contact me if you want to try SI. So. No questions? Oh, yeah, Dr. Kiley.
Does silicone have any impact on disease situations?
I actually saw a much higher, I didn't include that data, and I'm not a pathologist. And lucky for me, Russell is helping take that data for collaborator growers that we've just started trials for. But I saw the biggest impact on fungal pathogens. The mycelium somehow, yeah, it decreases them. Can't catch hold, that's what I've read in the research, but it greatly reduced, I would say the most, fusarium and botrytis. More than, I mean, we had a reduction in half the population of thrips. So the sprays were able to grow to maturity, so it doubled the yield, but even more than that on fungal pathogens. Bacterial and viral, I don't know. Yeah. Yeah.
With KNF, but it seems like it has about 100 million different inputs that you have to create and put on there. I was wondering how many of those you actually did.
No, that's a great question. So she's a little bit familiar with KNF, and she knows there's a lot of different inputs you have to put in. Lucky for us, we didn't make them. We have a source that makes them. So we put all of the ones that go on top of the plant. That's like OHN, PFJ. I have them. I can't always remember them all. I wrote them down. WCP, that's the phosphorus, and BRV. They're all stand for something, and they are a kind of a recipe you make in your backyard. And there's a website. There's a you can Google Korean natural farming, and you can get all of this information. Yeah. Thank you, guys.
To add a little bit more to what Joanna said, since R&D did, award actually 2 contracts to do our work on the Korean natural farming. The small backyard growers were the ones who picked up on Korean natural farming. And so they used to have a lot of training here on doing Korean natural farming, but it was backyard growers who were interested in growing their own food or raising their own livestock. When I moved to the county, Jane Horike was very active in working with the Korean natural farming group, and they would bring over Master Cho. Again, it was for the small backyard producers. So it reached a point where in my discussions with Jane was that I think we've done enough training for the backyard growers. And so we shouldn't support these projects anymore until they move into either commercial operations or the ornamental industry. And so when Dr. Bloese submitted her proposal for Korean natural farming in the anthurium production, and later on also had expanded it to Kentia palms, which unfortunately has had to close, not for that reason of Korean natural farming. But once that came in, then we stepped forward again to say, okay, we will support this project, and it was well written. And we do have several council members who are very interested in reducing the amount of synthetic pesticides and chemical fertilizers that's being used on this island. So more so, it got their support because it's a university project. They need to get a resolution from the council to enter into an agreement with a state entity, and they were wholeheartedly behind it. So, I just wanted to point that out that that this was one of the first, in fact, the first contracts with Korean natural farming that involved ornamental research. So, thank you, Joanna.
No, yes. Thank you, Glenn. Can I just add to that? I forgot to mention we are doing the second year of that funding is a greenhouse trial with KNF, so that we can not just do KNF in addition to conventional, but KNF alone and compare the two. So next year, I'll know.
Thank you.